Hello everybody, tonight's notes are going to be on pages, 81 to 82 of your workbook on function composition. So let's get right into our notes. What is function composition? So function composition is, it's substituting or plugging in one function into another function. So blast from the past, last year, you were asked to do things like f of 5 means plug in 5 wherever you see x. This year, let's apply our prior knowledge to our new knowledge. Let's say I said f of g of x. F of g of x is how I would say it out loud. Means plug in function g wherever you see x. And I want to use the language first, and now we're actually going to see what this notation means. So last year we got used to evaluating a number, like here 5. If I said f of 5, wherever I saw x I would plug in 5. This year we're plugging functions into other functions. Let's actually see what this looks like with number 1. Notice this is under notation. Oh, I'm sorry. This is its own note. Apologies. The notation could be like this, like I just wrote up here, or f, and then there's a little circle, like an open circle, f of g in parentheses of x. Both mean f of g of x. So of, excuse me, of is the key word. F of g of x. This here does not mean multiplication. Composition. Composition, composition, composition. Keep that in mind. Let's practice with number 1. Number 1 says, given f of x equals 8x minus 4 and g of x equals x plus 11, find, above let's put in words, this reading left to right, f of g of x. Excuse me, and you'll always be given the two functions. You don't have to make these up. They'll always be given. So it means we're starting with f. A strategy is to actually write down the first starting function. So our starting function is f of x equals 8x minus 4. That's going to be our guide for this entire question. Then ask ourselves, what's being substituted in? G of x is my input. So making a connection to last year, instead of g of x, if you had seen like a 5 right here, you would say, oh, I'm plugging in 5. But now there's a function there, g of x. So now we're plugging this in. To help us with that, use this left side here to keep track of your notation. So f of x is now going to become f of g. G is x plus 11. So g of x is what I'm supposed to be plugging in. Maybe I'll use a yellow marker, just so you can understand where I got that. G of x is what I'm plugging in. G of x is x plus 11. So now this notation tells me wherever I see x, I am plugging in x plus 11. Following my guide, I just took care of 8x. That minus 4 is still on the outside. From here, it's just using our algebra skills and distributing this 8 to help ourselves out. So let's send in the 8. Multiplying 8 times x is 8x. 8 times a positive 11 is 88, positive 88, minus 4. Last but not least, combining like terms, we get 8x plus 84, and we are done. Let's try with B. Order matters. So B, how would you read this out loud? Look at how we read A out loud. Can you figure out how we would read B out loud? Well, I see G is first. So I'm going to write G of, and then what's getting plugged in? F of x. So I write G of f of x. G comes first, so I write it first. G of x equals x plus 11. Then I ask myself, what's getting plugged in? F of x is getting plugged in. That's my input. So I write G of, well, I need to know what's f. To know that, I go up and I look. F of x equals 8x minus 4, so that goes right here. See the connection? G of f of x has now become G of 8x minus 4. So wherever I see x, I am plugging in 8x minus 4. That plus 11 is still there, so I bring it down. Just keeping this all color-coded. So writing that first function really helps me make sure I don't forget anything. Now, there was nothing in front of x, so there's nothing to distribute. I don't need those parentheses. I'll drop them. And now my last step is just to combine like terms. So negative 4 plus 11. Negative 4 plus 11 is 7. So I'm all set. So notice, order matters. Here, F came first. We were plugging in G. Here, G came first. We plugged in F. And notice the answers come out different. The best way to get good is to practice. So let's keep going with number 2. We're given two new functions. F of x equals x squared minus 6x plus 1. G of x equals 3x minus 9. A. How would I write that in quotes? What am I going to write? I'm hoping we're all saying to ourselves G of f of x. G of f of x. So which function comes first? G of f of x. So G comes first. So I write G of x first. G of x equals 3x minus 9. Then I ask myself, what is the input? What is getting plugged into G? Well, let's see. G of f of x. So f of x is the input. That's what I'm plugging in. I don't have to guess at what f is. I'm told. Check it out. F of x equals x squared minus 6x plus 1. So this is what's getting plugged in. To keep track of that, I'm going to go over here and I'm going to write G of x squared minus 6x plus 1. So now I have something visual on my paper that tells me wherever I see x, this is what I'm plugging in. And then I follow this as my model. So 3 parenthesis, my new input, x squared minus 6x plus 1, close parenthesis. And then minus 9 is part of this. So notice, this was my input. Wherever I saw x, that's what got plugged in. That's all I did. So 3x minus 9 became 3x, my input, minus 9. And now to finish this up, I just use my algebra skills. Let's distribute 3. That becomes 3x squared 3 times negative 6 is minus 18, and then x is still there. And then last but not least, 3 times a positive 1 is plus 3. That closing parenthesis tells me I'm done distributing 3. Minus 9 just gets brought down. And then my final step, combine like terms. Do you see any? Let's see. Nothing else like x squared. Minus 18x. Nothing else that has x by itself. But I do see plus 3 and minus 9 that I can combine. So my final answer will be 3x squared minus 18x plus 6. And I'm done. Let's work on B together. B says, you try. What would you write above here? Order matters. F comes first, so I say f of g of x. F of g of x. As soon as I see that, I know f comes first. So I write f, whatever it is. So f of x, I'm told, is x squared minus 6x plus 1. Next, I ask myself, I don't like that line, make it straighter. Next, I ask myself, what's getting plugged into f? F of, change this color. My input is g of x. So over here, I keep track of that. I write f of, and then I say, well, what's g? Let's go look. G of x equals 3x minus 9. So this just became my new input. Wherever I see x, this is what I'm going to write. And this is where, if you write this starting function, so to speak, if you write the starting guide function first, you'll never get it wrong. Because I'm not going to overthink this. Literally, where I see x, this is what I'm writing. So this becomes 3x minus 9 all squared, because this was x squared, so x is now 3x minus 9. The square is still there. Minus 6 times, where I see x, I write 3x minus 9. Close it, plus 1. So I'm just going to pause for a second, look at what we started with, and now look at what it looks like where wherever we saw x, we plugged in g. This is the big step. This is where the composition happened. We plugged one function into another. The rest of this is just using our algebra skills to figure out what this ends up being. So 3x minus 9 all squared means I have 2 of them. So it's got to be 3x minus 9 times 3x minus 9. We'll just write it out for now. We'll do it on the next step. This negative 6 we can distribute in to be minus 18x plus 54. And then this plus 1 is still at the end. This is where keeping our work nice and neat, doesn't matter how, whoa, look at all this. That's fine. We have the skills to do it. The key is to keep it neat. So notice this line down the equal sign is keeping all of my equal signs lined up. I'm being clear. I'm leaving a little bit of space in between each step. And now I'm ready to look at this here. 3x minus 9 times 3x minus 9. We're going to use our arrows. So 3x times 3x is a 9x squared. 3x times negative 9 is minus 27x. Negative 9 times 3x is minus 27x again. And minus 9 times minus 9, or negative 9 times the negative 9, positive 81. All of this here needs to be brought down as well. So minus 18x. If you choose to combine like terms right here, that's fine. Plus 55. Or leave it, because either way we're about to combine like terms for the rest of it. So combine like terms and we're done. 9x squared. Do you see any other squared terms? Nope. I don't either. So 9x squared comes down. Let's see. This is like terms with this. Both are x to the first power. Do you see any more? Ooh, check it out right here. None others. So you can either use your calculator or off to the side. We're looking to combine in the negatives these three numbers. So I'm just going to add them up together, and then I know that my answer will be negative. So 7 and 7 is 14, plus 8 is 22. Carry the 2. 2, 4, 6, 7. So I know that this is going to be minus 72x. Or in your calculator, just do negative 27, minus 27, minus 18. You should get negative 72. Last but not least, I've got a positive 81 and a positive 55. So again, off to the side, 81 plus 55. 1 plus 5 is 6. 5 plus 8, that's 5 and 5 is 10. Plus 3 more, 103. Excuse me, 1013. Oh, sorry. 13. 136. Mental math, just to explain what I was saying in my head. 5 plus 8 is like 5 plus 5 plus 3. So I broke up 8. 5 and 5 is 10, and 3 more is 13. Or again, in your calculator, just go ahead and do 81 plus 55. Either way, you will get plus 136. Oh, right. Sorry, I still don't like that box. We got one more to talk about, which is C, part C. On your own, what are you going to write in words for what this means? Off to the side, what are you going to write? G comes first, so I'll write that first. G of. And then what's getting plugged in? It's G of G of X. So if that sounds crazy, what you're doing is plugging G into itself. The process doesn't change. So G of X, G comes first. So I write that down. What is G? G of X equals 3x minus 9, so that's what I write. G of X equals 3x minus 9. That's my guiding function. That's my starting function. Line down my equal sign. Then I ask myself, what's getting plugged in? Well, it says G of X. What's a color I haven't used yet? I'll go get a new one. Let's do bright green. All right. So G of X that looks too much like green. I'll stick with yellow. G of x is getting plugged in. So this becomes g of, what's g? G is 3x minus 9. So that's what's getting plugged in. So wherever we see x, that's what we're going to plug in. And then minus 9 is still over here. So check it out. 3x minus 9 was the input. Wherever we saw x, that's what we plugged in. And to wrap it up, we're going to distribute and see if there's any like terms that we can combine. So 3 times 3x and then 3 times negative 9 would get us, let's see, 9x minus 27 minus 9. Do you see any like terms? Hoping we say, yeah, negative 27 and negative 9. Take a second. What is 27 minus 9? If we're not sure, off to the side. They're both negative, so I can add them together and make my answer negative. 9 plus 7 is 6. Carry the 1. 36. So minus 36. And that's it. Looking ahead, I just want to see. Page 82, numbers 3 and 4 are where we're going to move to. So if you needed a second to wrap up that other example, go ahead and press pause, and then when you're ready, join me on number 3. I'm going to do number 3, and I'm going to leave number 4 for class tomorrow as a really nice SAT question for us to discuss as a group. Number 3 says, given these two functions, f and g, find. Right away above, I'm going to ask myself, what does this mean? So g is first. G of f of negative 3. Ooh, this is new. So, with one that I actually have a value, like this is a legit number, negative 3 is getting plugged in, this is going to be a 2-part process. Because we can actually do this. Like if this just said g of f of x, there's nothing you can do with that. But that's not what it says. It says g of f of negative 3. I can actually calculate that. So ones like this, we're actually going to start from the inside out. What I mean by that is, step 1, calculate f of negative 3. We're going to do that first. Then plug result into g of x. The answer will be a number. Best way to understand what I just wrote is for us to actually do it. So the strategy here is if there's f of a number on the inside, we're going to do that first. So let's calculate f of negative 3, which we all know how to do from 9th grade Algebra 1. So wherever I see x, I'm going to plug in negative 3. Pause, you finish. From memory from last year, from our bell ringers that we've done on this, I'm hoping that we'll be in good shape. When you're ready, check answers with me. So I get negative 3 squared is 9, so this becomes 2 times 9 minus 21 minus 12. That's 18 minus 21 minus 12. 18 minus 21, that's negative 3 minus 12. Negative 15. Do we match? Hope so. If not, check your signs. So we just did this first part. Calculate f of negative 3. Now we're going to plug that into g, because think about what this really means. It says g of f of negative 3. Well, you just found f of negative 3. F of negative 3 is this number. So this becomes g of negative 15. That's what it means by plug the result into g, because you just found it. So now in this g of x function, wherever I see x, I plug this in, which is going to be negative 4 times negative 15 plus 1. Let's see. Negative 4 times negative 15. Well, I know 15 times 2 is 30. So that means 15 times 4 is 60. Negative times negative is positive. Plus 1. Our answer is a single number. So this was the two-step process. Ready? This was step 1. This was 2. Notice, completely separate operation. Get rid of this so it doesn't distract. We actually calculated what we could first. We could actually find f of negative 3. We got that number, took that number, and then plugged it into g to finish it up. So unlike the other ones where, if you look at the answers for the first ones we did, notice x is in all of the answers. But there will be composition questions like what we just did, where we are actually able to evaluate a number from the inside first. We did that to start, and then our 2 steps. Found it, plugged it in, and finished. And we'll keep practicing. Right? But I really want you to mentally kind of have this conversation off to the side on how the approach is different. If you would like to give number 4 a shot, that would be really cool. There's actually no, this is missing a parenthesis. There is no math here. It's can you correctly use the table to get to your answer. So, rock stars out there, give it a shot. Let's see what you get. Otherwise, great job on today's flipped notes on function composition. Can't wait to see you tomorrow, and we'll keep practicing. Bye.